Thank you all for coming tonight to listen to this new presentation on soil remediation. So, if you know me, you know that sometimes I like to go down the rabbit hole. Some of these things are kind of interesting. Most of them have something to do with horticulture, plants, sometimes it's urban wildlife, but I might hear about something and think, be kind of interesting to know a little more about. I apologize. I've given like three programs this week, and so my voice is a little bit ragged. But sometimes I'll hear about something and it'll pique my interest, and I'll say, let's kind of do a deep dive on that. I want to learn a little bit more about it. So, for you brave souls that turned in to watch my soil remediation, you're probably scratching your head going, I don't really know what soil remediation is, but game, I'll come and see what it is. So, we're going to take a deep dive into the scientific aspects of it. It does involve plants, not everything, but there is a component of it, and we'll zero in on that. If you get to the end and you're like, wow, that was pretty cool, I like learning that, feel free to reach out to me. I'm happy to share the slide deck if you're interested. And that way you can keep that for research purposes. If you like the recording or you want to watch it again because maybe you get a little tired at 2 a.m., the link and all of that will be on the very last slide, along with my email address and other valid information for getting a hold of me or anything that I do. So let's jump right in. So, soil is kind of the basis of everything. In extension, we teach about how the soil biome is very important to pretty much anything that you do. You can't grow anything in it if it's off. You can't um, build anything if you don't have it. It can determine if you have an unhealthy biome, how much crop you get versus how little crop you get. So there's a lot to kind of look at and ponder on that. Soil, if you don't have healthy soil, will really affect everything. So that's why I kind of wanted to do the soil remediation, because I read some article someplace and it talked about how you can use plants to alter the biome of the soil, especially after contamination. And so I thought that's pretty cool how plants can actually transform the soil. Many of us already know about nitrogen fixers like clover or legumes, and then how you can put a heavy nitrogen user like corn or something like that in the soil afterwards. But there's a whole bunch of other plants out there that can uptake heavy metals, organophosphates, all sorts of contaminants and other things. And so I thought, wouldn't that be cool to learn a little more about that? So, what does soil do? Well, it sequesters carbon. So, trees and everything like that, that's a carbon sequestration. It'll help purify water. It can help reduce soil contaminants, all the little microbes that are in there. It'll help regulate the climate. Nutrient cycling, of course, when leaves fall to the forest floor and then the decomposers break those down. It's a habitat for organisms like earthworms and bugs. It helps regulate floods. Obviously, different sized soil particles can hold water, more water or less water. You can source pharmaceuticals and other genetic resources. There are, bacteria out there that they can use in pharmaceuticals. It's a foundation for human infrastructure. You can't build on it or without it. It's a way easier to build on soil than it is rock, I'll tell you that. Cultural heritage, Indian mounds, things like that, Native American mounds, provisions for food, fibers, and fuels. I mean, it really is the groundwork for everything. And part of that are the soil biota. So these are the little guys that live in the soil and that keep it all running, keep it all going. They have their own little ecosystem in the soil, and that's going to include your bacteria, your fungi, your protozoans, nematodes, little microscopic worms, earthworms, insects and arthropods, and algae, actinomycetes, and other little microbial communities. They all live in there and they all play a part in how healthy your soil is. They also play a big part in the soil remediation. We're mostly going to focus on plants, but we'll touch a little bit on some of the others. So, what is soil remediation? Well, it's going to be basically cleaning and restoring and improving some kind of a degraded or compromised contaminated soil. So you're going to remove the contaminants, and that could be heavy metals, hydrocarbons, pesticides, anything like that. Pretty much anything that man isn't very careful about handling. There's techniques, so it'll include physical techniques, like you're actually washing the soil, chemical, where you're neutralizing it with another chemical, biological, and that's where we're going to focus in on with phytoremediation, bioremediation, that kind of stuff. Environmental restoration, so that's basically trying to get it back to the same state it was in prior to all of that to make it safe to grow things again for construction and other ecological balances. I'm sure many of us know a lot about the Superfund sites. There are some that the government just threw their hands up and said, we can't do anything. Times Beach is one. I think there's one up by Missouri where they're too contaminated. So in situations like that, they just wall it off. But if you have a smaller problem or something like that, a lot of times there is a fix that you can do to clean it up. So it's kind of interesting, especially if you think that plants are so marvelous that they can actually do a lot for us with that respect. So we want to kind of take a deep dive into that. We want to find out, how do they do that? What do they call it? And then we'll look at some plants that you can use for that. So when is soil remediation necessary? Well, floods. So after Helene came through, and we know what happened up in North Georgia and on up into South Carolina and North Carolina, those poor people along those main rivers, all of that, their land flooded out. They need this. A lot of stuff gets into that flood water, petroleum products, pesticides, um, bacteria from septic tanks, all of that stuff. And then when that recedes and that mud is left behind, that's a big problem. Industrial contamination. You know, you have a lot of like we'll say dry cleaners. Sometimes you get the chemicals and they spill. Mining operations, you see in the top right, that's leachate from a mine. Severe erosion. Wildfires with toxic ash, like what happened out in California, chemical spills, agricultural runoff, leaching, oil spills, compaction. That's kind of an easier one to fix in some respects. Health, environmental risks, and things like that. So all of these are when you would need some type of soil remediation. Well, what about in your own backyard? Well, sometimes you need a minor form of that in your backyard. And so while this kind of will focus more on the bigger picture and trying to educate you so you understand what it's about, the plants at the end of this will kind of give you an idea of what's possible, stuff that you can grow, that you can make better. In your backyard. So, like compacted soil. Maybe you own a little bit of property and Uncle Bob's been planting or been driving and parking underneath that old oak tree. And now that soil's super compacted and the oak's not so happy. What do you do to fix that? Septic system overflow, like you see in that top left picture. Well, what do you do to fix that? Nobody wants to plant a vegetable garden where it just overflowed and you've got a lot of fecal matter. So, how do you fix that? Pesticide spills. Maybe you were in your kid was playing soccer, or basketball out in the driveway, and you had your Roundup, and it was sitting there right at the edge of the garage. Maybe that ball knocked it over, and it ran down the driveway and rolled off into your yard. Now you've got a pesticide spill. Flooding. Removing large debris, planting a cover crop to kind of clean that soil. So, lots of ideas here. Maybe you have an area of your yard that just isn't thriving and you have lots of problems. So getting a soil test to figure out what's going on. And then you can do something like the radish method, where you're planting radishes in there to help replenish the soil, add some organic matter, things like that. So there's things that you can do and you may have a need for in soil remediation in your own backyard. So there's a lot of different types of soil remediation. So I'll just run through kind of the main ones and then we'll focus a little bit more. Um, I'm not going to read everything. So again, if you want a copy of the slides, feel free to request them. I am happy to provide. It's only an hour and I like to talk, so sometimes I have to cut it short. First, it's going to be encapsulation and stabilization. So this is where you're going to entomb something. I think on the slide that I'll talk about it, that's how they did with Chernobyl. They entombed that whole thing in concrete. You have natural attenuation. It is basically where you just kind of leave it. So you don't plant anything on it. I'm going to go with a Superfund site where they wall it off with a chain link fence and just let it go. That's pretty much what's happening there. They're not really doing anything. They're kind of allowing nature to take its course and to slowly break down whatever that toxin is. Electrokinetic remediation, that's where they're going to use electrical currents that run through the soil to help break things down. That helps extract heavy metals like arsenic and lead from the soil. You have thermal remediation, that's where they use heat to treat the soil. They have these big machines that they heat the soil up and that vaporizes things. Physical remediation, that's where they're going to be actually removing or isolating that contaminated soil. They may scrape off the top and then just get rid of it. And then they may also take that off and treat it off site and then bring it back. Chemical remediation, they use some type of chemicals to neutralize whatever that is that's causing a problem. And then the one we're going to focus mostly on is the biological remediation, where you're going to use living organisms to remove or degrade those contaminants. So plants are going to absorb and stabilize those contaminants. And we'll go into a list so that you can kind of see what. So encapsulation, again, this is what they used for Chernobyl. That is Chernobyl on the top right. They basically entombed the whole thing in concrete. And so everything you use concrete, use asphalt or some type of a synthetic liner or something like that. And it's going to seal all of that. Used in landfills, they put a seal in the landfill. They don't want it to leach out. It can prevent leaching of contaminants into groundwater or air. Nobody wants that stuff leaking into your groundwater. So this is a good way to kind of prevent that. They also do that with toxic waste. They'll put a concrete liner in, very safe. You do occasionally have to go in, and they have had to add another one over the top of Chernobyl, but this is a good thing for that. Natural, where you just kind of leave it and monitor. So your microorganisms that are just there naturally are going to break things down. So basically, you're just using time. You're roping it off so that nobody goes in there and comes in contact with whatever the contaminant is, and you're just letting time kind of do its thing. And so all the little natural bioorganisms out there, that soil biota that I showed you the slide of and talked about, all those little guys are out there and they're doing their thing. They're just, working through that, and it's going to bind to the soil particles. It might dilute a little bit. They may capture the runoff water, that kind of thing. But it's what they use to manage hydrocarbons and pesticides and other organic type pollutants. It's pretty cheap as compared to some methods, because basically you're not really doing anything. And, you just have to basically have time on your side. Electrokinetic soil remediation. So again, they stick these electrodes into the soil, and then a very low voltage direct current is applied, and they just kind of let it do its thing. So you're going to have electromigration, electroosmosis, and electrophoresis. Some people in labs might be familiar with electrophoresis, but basically electromigration, you've got particles that move from one electrode to the other, and then electroosmosis, water with the dissolved contaminants kind of flow through to that cathode. Your positive to negatives, and then electrophoresis, where particles in some kind of a suspension are going to move in that electrical field. And so they use that for heavy metals, maybe radioactive things, organic pollutants, that kind of stuff, and in clay type soil. So there's some examples of how it works there over on the left. This is thermal remediation. So and they come in both portable and permanent structures. So this one, I think it looks like it's probably permanent. So in this case, you would haul the soil out there, they would run it through this facility, and it would basically heat that directly, and then that is going to either, in this case, thermal conduction, where the heat's going to go in there using conductive methods and then cause whatever the contaminant is to break down or vaporize. Electrical resistance, you're going to heat that soil as it passes through, and then it's going to change. And then steam enhanced. So they're going to inject that into the soil and get those contaminants mobilized. So again, this is where they usually haul it to. But if they're dealing with a smaller site, they may have a mobile facility that they can bring. But basically, it's going to, whatever's in that soil, it's going to remove those embedded contaminants. So if you have, maybe a quarter acre or something, they'll excavate that down, haul it all over to the facility, and then they'll treat it there. And then they can actually bring it back. Physical remediation. So this is going to be excavation and removal of that soil. You might wash it. You might use some type of vapor extractor and then capture the vapor off of it. There's a lot of interesting things here. You may actually cap the soil. So you can see they've got a tarp over that soil up there. You're not entombing it, in other words, but you're using some type of a temporary measure. Soil vapor extraction, soil stabilization. This is going to help prevent leaching into groundwater. You don't want to inhale this stuff, and it's going to help keep that stuff out of the fields, so that, like, for instance, if you've got a contaminated site where maybe a farmer had some pesticides that spilled, they can clean that site up, remove it off site, and then they can use a different type of technique to get rid of it. Next up, chemical soil remediation. So this is where you're going to actually, if you're a chemistry person, this is where you're going to shine. So you're going to use things like lime or concrete, and that's going to bind whatever that chemical is, that toxin is. You might use oxidation agents like hydrogen peroxide or ozone that break things down into harmless substances, so like water, so that it's safe to go back into the environment. Contaminants and things like that, you extract that or leach it from the soil. And then also the electrokinetic remediation, where you're using electricity. This can kind of fall under here also. Some of these are used all in conjunction with one another. And again, heavy industrial pollutants, heavy metals, pesticides, things like that. It's really quick, much like the electrokinetic is, and fairly efficient. Can be kind of expensive, but it can be tailored to whatever it is that is the problem. And then this is the one we're going to focus on, the biological remediation. So you're going to use microorganisms like bacteria or fungi that are going to break things down, break down organic pollutants. Phytoremediation, that's plants. Mycoremediation of fungi, and composting. And you can use it for treating hydrocarbons, because carbon, that's natural, pesticides, heavy metals, and other pollutants, often seen in ag, industrial, urban settings. It can be pretty cost effective, and hopefully at the end, you're going to enhance that soil biome so you can go back to using it the way that it was. While it takes a little bit more time than chemical or electrical or some of the others, it is more natural. All right, so types. Bioventing. So this is you're using air and water injecting that in there. And you're stimulating those little microorganisms in the soil to kind of speed up and degrade things. The mycoremediation, that's using fungi to break those things down, to break down those organic pollutants like petroleum products. That they work on that. The enzymatic systems in there break them down. So like if you have an oil spill or something like that, you can use bacteria to come in and break that down along on a beach. Composting, a lot of us do that anyway for breaking down organic matter, but sometimes it's used in a much larger capacity. Land farming, that's where you spread the the soil over an area, and then you're going to basically enhance that microbial activity so that it will break whatever the issue is down and maybe hydrocarbons or something into less dangerous things. Bioaugmentation, adding bacteria in to target contaminants. Biosparging, air is injected in, just another, this is used for volatile compounds. Biostimulation, adding nutrients in to boost that activity. So you're feeding those little microorganisms. And then phytoremediation, using plants to absorb or accumulate or degrade contaminants. We'll focus mostly on that one. This is the important one, and this is where most of the information is going to come from. But I did want to go over the other stuff because it's kind of a lot of information, but I kind of look at it as, you never stop learning. And maybe you guys want to come to these because you learn a little bit more than you would at your typical webinar. And, you go play trivia, maybe you'll know the answer, right? Phytoremediation. Okay. So again, this is plants that are being used to help extract, break down, or remediate some type of a toxin or contaminant. So you've got phytovolatilization. So that's where the plants are going to uptake those contaminants and then release them through transpiration into the environment after they've already done their magic and broken them down into less dangerous compounds. No extraction. Plants are going to absorb things like heavy metals into their roots and shoots. So that's the process by which they uptake those. Phytostabilization. So after they uptake all of those compounds, they're stuck in the root system. So that means that they've gotten them out of the soil. We don't have to worry about the soil washing away into the streams or anything like that. They're uptaked and sequestered in their root system. Phytostimulation or rhizodegradation, that's when the roots kind of stimulate that microbe activity in the soil, which then helps all of that stuff break down. So it's kind of a symbiotic relationship. All those microbes in the soil biome are working on it, just like the trees are. Phytofiltration, that's where the roots are going to purify the water by absorbing or concentrating those contaminants out of the water. Phytodegradation, that's where the plants are going to break all those nasty pollutants down, like pesticides and things, or hydrocarbons, into less harmful substances. And again, sequester them in their tissues. So no need to know all of those, but now you can say that you heard it, and now you know a little bit more about the actual label on those processes. So plants that absorb heavy metals. Sunflowers, mustard greens, and we'll take a little bit more of a deeper dive into each of these, but sunflowers, mustard greens, corn, sorghum, cattails, water hyacinths, pumpkins, ferns, potatoes, maple, cherry, and plum trees, and strawberries and blackberries. So those do well at absorbing heavy metals. Here's a little blurb on the wildflowers in California. So this is kind of interesting. When you have an area along a stream bank that needs some remediation, maybe you've got no vegetation holding it down. In this case, everything burned. So there really wasn't any cover there to prevent mudslides and areas from getting scoured out. There was a lot of toxic ash that was left behind, which, of course, you don't want in your waterway. You don't even want it on the soil. So they're having to do a lot of remediation out there. And what they did is they used these straw, circular, long, snaky looking things called wattles, and they're usually straw. But you can use coconut coir or other things. But they were impregnating them with mushrooms, and so they had these oyster mushrooms impregnated in there for that those fungal spores to kind of come in contact with some of those toxins, to absorb them instead of allowing them to flow into the waterways and then away and contaminate the soils and all that. So the mushrooms were actually sequestering that toxic runoff or helping to do that. So I think that was pretty cool. So you can read more about it if you want to there. Plants that decompose hydrocarbons and organic contaminants, that would be uh, petroleum products and things like that. Fescue grass, tall fescue, Bermuda grass, blueberries, and raspberries. Plants that restore soil nutrients, so nitrogen fixers. Alfalfa, that's a hay. Um, Best known for feeding animals. Horses love alfalfa hay. Clover, red clover, white clover, there's different kinds of clovers. Wheat, soybeans, peas, and beans. So a lot of these both are used both as cover crops and as an actual crop. Plants that remove excess nitrate. Willows, watercress, duckweed, water lettuce, and sunflowers. And then we'll talk about a little bit about regenerative agriculture. So that's kind of a tagline right now, like a big thing in the news. So regenerative agriculture. I actually did a focus group not too long ago, and they talked about regenerative agriculture. And that's basically just improving the soil health or the soil biome by adding organic matter in and promoting that microbial diversity. That's all fancy talk for making the soil bugs happy. Really, that's all it is keeping the soil bugs happy. All the little microscopic bugs up to the regular sized bugs. You're just trying to keep everything healthy and in balance. So you're trying to minimize any soil disturbances. So you want to use no-till methods. My last program was on no-till methods. So if we see a theme here, sometimes I start going down the rabbit hole and I'm like, it's cool. That's cool. I should talk about that. So using no-till methods, ones where you don't have to dig into the ground. You just kind of do stuff on the top. You do things to make things healthier. Cover cropping, that's going to cover the soil to help prevent erosion and increase the organic matter there. That last presentation talked all about that. That should be up on the YouTube channel now if you want to watch that. Water management, you want to keep water on your property. So we'll have an advanced training later this year for master gardeners in July. That should become available to sign up for mid-June, I believe. But that's going to take a deep dive into water management and how to keep that on your property. So rain gardens and all kinds of ways to make your soil healthier so that you're doing better for the environment. And then carbon sequestration. So, the whole global warming thing, whatever, but keeping acting as a carbon sink. So making sure that you've got plenty of greenery out there so that, it can uptake the carbon dioxide and act as a carbon sink. So now we're just going to go into the different plants and kind of what they do. So sunflowers. I love sunflowers. Some people like to eat the seeds. We like to use them as a trap crop for leaf-footed bugs. But sunflowers are actually used for phytoextraction and volatilization. So they're called hyperaccumulators, meaning they can store high levels of heavy metals like lead, arsenic, and cadmium. Who knew, right? Um, and they can keep them in their tissues and it does not act as a toxin to them. So their root system is very efficient at uptaking all of these and concentrating them in their leaves and their stems. So conversely, if you have a site that's contaminated with any of these, you could plant sunflowers on there and the root system will uptake that into the tissues. And then you would, of course, dispose of the plant material accordingly. So after they've removed all of that, then you would, incinerate or use one of the other methods that we talked about in order to get rid of the tissues. And they're good at either wet or dry conditions. So you can use them out west where it's really dry, and you can also use them over here where it's a little wetter. Mustard greens. So some people like to eat them. They're a little spicy for me. I'm not a huge fan. But mustard greens do the phytoextraction and phytostabilization. So they too are pretty good at absorbing heavy metals like cadmium, lead, and arsenic. Don't worry, you probably don't have that in your soil. This is if you have a site that you know is contaminated, we get calls from people that are really concerned and think that their backyard might be contaminated, but unless they were storing, you know, transformers or something there in a previous life on that land, you're probably okay. It's nothing I would be too concerned about. But these will concentrate it just like the sunflowers were. So they're going to sequester all of that, those contaminants, in their above ground tissues or their leaves, and get that out of the soil and concentrate it. So then you can just remove the tissues from plants and dispose of it however you need to. And it's kind of interesting. So, within the cells, they're going to use little proteins that bind the molecules and stuff like that to help neutralize. It's kind of interesting. Again, not too much of a deep dive into it because, your eyes could probably cross, and this is something for a very specialized class. But I don't do college level classes. This is about as close as you're going to get. So, hopefully you'll find this just as interesting as I do. Indian grass or woodgrass. So if you have an area that is rather large, this would probably be a good one. So basically a prairie grass. It's a phytostabilization, meaning it's going to interact with the microbes in the soil. It helps fix nitrogen and enhances those nutrient values. So maybe you have an area that's been farmed heavily and, it wasn't really well taken care of, and you want to make it a pasture, or maybe you want to put your garden there, and it's pretty much devoid of the nutrients that you need. Well, throw some of this stuff on there and let it go fallow for a few years. Fallow just basically means that you're not planting anything on that, not a crop or anything like that that you're going to harvest. You're just going to let it go natural. It's a prairie plant, so it's got a fairly deep root system. So it's good if you have an area that's eroding. Think maybe a hillside that's not able to hold much soil. This is a good thing to have there. It will contribute its own organic matter, which enhances the soil biome. And over time, that's going to make it a more fertile soil. It also, of course, just like any other plant, is going to sequester carbon, so that's a good thing. And it's very drought tolerant. So if you have a natural area, maybe an old pasture or something like that, you can put some of the seed out there, just kind of let it go. It will naturalize quite well, and it's a good thing to have to kind of help pump that soil up after it's been heavily farmed. Poplar trees. So poplar groves are actually used in certain situations where you have uh, hydrocarbons, volatile organic compounds, and things like that, and the soil's contaminant. They'll come out here and they'll plant those poplar trees and just kind of leave them. And what they're going to do is they're going to help break down those pollutants. And they do it with phytoextraction. So their root systems are going to absorb those heavy metals, cadmium, lead, zinc, and then they store it in the wood and the root system. That root zone is also going to enhance that microbial community. So mycorrhiza, which is something that most gardeners are going to know is a good thing to have in your soil. That's basically the same thing here. And they grow really fast, generally speaking. So they do a good job of hyperaccumulating all of that stuff, growing big and tall, stabilizing the soil, getting those contaminants out. They're a really good tree to have for that particular reason. Tall fescue. So that doesn't do really well here. If you have a shadier area, it does better. It doesn't do well in full sun. But tall fescue is pretty good at doing phytoextraction, so the sucking up things that out of the soil, absorbing toxins, and stabilizing them in the root system and keeping them within that plant. So it also will host fungal endophytes. So if you're into horses, this is a little trivial tidbit. If you're into horses and you have a breeding facility, or maybe you just have a horse and mare that you want to breed, don't ever put them on fescue. Tall fescue is bad. If they're just out there grazing, that's fine. But if you're reproducing your horses, this can actually cause a thickening of the placenta and that baby can't break through. So if the mare goes into labor and she has that baby in the middle of the night and you miss it, you're probably going to lose the foal because they can't break out through the placenta. So generally what they do is they'll haul the horses off at, I think it's the last 30 or 45 days and finish them on a Bermuda, or put them in a stall just to get them off so that the endophyte, which is what's in there and causing that problem, is no longer an issue. But aside from that, just as a useful plant, it does have a fairly deep root system and it can concentrate any of those toxins into its root system. So, you know, it can thrive. You see it lots more probably up in the upper Midwest, all the way down through the Midwest into the mountains. You do see it here, but again, it's pretty hot and it's a cool season grass. It tends to thrive best in the spring and the fall. I actually have it in my front yard, but it's not a big fan of the South. But it is used quite often in hydro seeding and things like that. It's pretty adaptable. Willow trees, so besides using them for stabilization on stream banks, which they're very useful for that, they also are very useful for phytoextraction, meaning absorbing all of those contaminants, stabilizing, and volatilization. So if you remember back to the volatilization, they sip that stuff up, they convert it mysteriously, and then poof, and when they transpire the moisture up into the air, suddenly it's healthy. So, next time you're driving and you see a willow along a pond, or if you see it on a stream bank, give it a little nod because even though they grow like weeds and most people don't really want them, except in the issues where you have an unstable stream bank and you need something that grows really fast, they do a fantastic job at both that. And then I also want to throw a nod in towards the fact that that's aspirin. You have black willow, Salix nigra, which is aspirin. You have salicylic acid, that is from a willow. So there's a lot of really awesome uses for willows, besides the fact that weeping willows are really pretty, but they also uptake a lot of nitrogen and they'll store that in the soil. They do use a lot of water, so don't put them in the middle of a dry lawn because they'll die. But if you have it near a pond or a stream or a river, they do wonderfully. They have a lot of microbial action going on around the roots, and they're a very fast growing tree. That's why they're so prized for doing stream bank stabilization because they do root very quickly and then will cover that area and protect it so it doesn't erode away. Alfalfa. So this is also a hay that I mentioned that used for horses and for other farm animals, but mostly for horses. Very prized, very expensive. I don't even know what a bale of alfalfa hay would cost now. I had horses when I was younger. Hadn't had them in a while, but last I checked, because you can't really grow it here, you get the blister beetle in there, and that can be toxic. But if you haul it in from another state, a bale of alfalfa hay, gosh, it's probably up to $25 now. I don't know. It's really expensive. But it's a nitrogen fixer, just like any other legume or pea or bean. It has a symbiotic relationship with that bacteria and its little root nodules. So if you grow this, it's going to fix that nitrogen in the soil. Most people are going to continue to grow alfalfa. They're not going to like harvest it and then get it out of the field. You just have an alfalfa field and then you harvest it. But if you have an area that you wanted to lay fallow for a few years and not put anything to grow in there, this is a good option. It has a very deep root system, so it's protective for the soil and it helps grow in there. And then, eventually when it dies, it'll open up those soil pores and add organic matter back to it. But erosion control, because of its deep roots, it does a good thing there. So it's mostly just because of being a nitrogen fixer that it's such a good plant, but it also will absorb heavy metals like that cadmium, lead, and zinc. So that will help keep it sequestered in the plant and not leaching into groundwater. Good old Bermuda grass. So a lot of us have Bermuda lawns and the phytostabilization. So it's going to help kind of clean up the site and keep all of those contaminants in its root system to prevent it from leaching into groundwater, the rhizodegradation. So all that microbial activity around its root system, those are going to help break, those little microbes are going to help break things down, hydrocarbons. So if your husband loves to work on cars and he's allowed the oil to drip out and pool in an area over there, this will help break that down into less harmful compounds. And enzymatic activity. So, without going too deep into there, again, breaking down those hydrocarbons. It has grows through rhizomes, so it's creeping. It's a creeping grass, and it will help keep the soil together. Conversely, it doesn't like it when it's hard pan clay, so you got to give it something good to grow into. But it will help keep that soil light and airy as long as it doesn't all wash away if it's on a hill or something. And honestly, even though it seems like it grows into the areas we don't want it to, and it's thick and lush in our flower bed, but sparse over here in our lawn, if we take care of it and we provide it a good soil to grow into, it will be deep and lush over there too. It's probably over in your flower bed because you're taking more care with the soil in your flower bed than you are with the soil over in your yard. Just as an aside, if you've had your yard for 10 years, and you haven't done any rehabbing on it, it's probably time to do some not overseeding, sorry, um, top dressing. So top dressing basically means you're going to go in the spring, you're going to do a core aeration on it, and then you're going to top dress or add probably, I don't know, an inch or so of compost or topsoil to your Bermuda lawn. And what that does is that's going to add more nutrients and soil to help cover those roots. Because over time, we lose a lot of that topsoil, especially if you have a real hilly yard. So you're probably noticing some sparse areas, and that could be because you've got super hard pan clay. You can help break that up and add some organic matter back into the soil. And then your Bermuda will be happier over here and stay out of your flower beds. No, just kidding. It'll probably still be in your flower beds. You'll always be fighting that, but at least it'll look good over here too. Corn. So corn it's a heavy feeder, yes, but it also is good for phytoextraction, meaning it's going to pull heavy metals out, lead, zinc, other things like that, and that's going to store, sequester in those roots. Um, the phytostimulation, especially with hydrocarbons and stuff, it's going to concentrate them in its plant tissues and sequester that. So it's going to suck all that stuff out, store it in its stem and its roots, and that's where it'll be. So then you can harvest, pull that up at the end, and then dispose of that however you need to. Um, Sometimes they're incinerated, sometimes they'll, some of those other techniques that I talked about that are used, that's what they will use, that's what they'll do to get rid of this stuff. Date palms, so phytostabilization, so it's going to suck those contaminants out of the groundwater to help prevent them from spreading. Obviously, pretty highly tolerant to salt water. You see a lot of them in tropical areas, beach areas, that kind of thing. They're actually monocots. They have a very tiny root system, and they can live in sandy soil, but they do a pretty good job of anchoring themselves where they are. So once they're propped up and they're established, they're pretty solid. Hence the reason that they can stay upright even though they get shredded to bits in a hurricane. So water management, they can retain and help filter a lot of that in saline soils. So that can help other plants that are around them that maybe aren't as tolerant of sandy soils, and they'll help sequester carbon. Cattails, and we're almost done. So phytofiltration, so they're going to absorb heavy metals through their root system, like lead and cadmium and nickel. Sometimes you'll find these things in wetland areas and also in and around ponds, retention ponds, and you kind of overlook them because they're just there. But honestly, wetlands, and we'll be doing in that advanced training, we'll be talking a lot more about why wetlands are so important because a lot of these plants do a fantastic job of filtering out nutrients, which is the primary one. That's the one that we usually, so like fecal coliforms, dog poo that flows off fertilizers, off the golf course, that kind of stuff. They do a fantastic job of uptaking excess nutrients so they don't end up in the water. And then you have blooms of algae, which are kind of disgusting, or have the water end up out into the streams. But they also do a fantastic job of uptaking the heavy metals. So if you have these in a wetland, and you'll note that in bioretention cells and in other green infrastructure that sometimes they'll go ahead and allow them to grow because you have parking lots. Well, what do you have in parking lots? You'll have oil, you'll have gas, you'll have other stuff like that that flows into these areas and they can help break that stuff down. So, yeah, they're kind of, yeah, nobody really gets excited about cattails, but they do a fantastic job of helping to filter the environment in a lot of different ways. So they're actually a good thing. And my little bit of trivia, I have a pot on my back deck that I thought for a while there had a blackberry lily or something like that in there. Turns out it was a cattail. It just popped up one day. I didn't remember to drill a hole in the bottom of my pot, and so it was very wet. We have a pond, neighborhood pond, about 2 blocks over. So apparently one of the little cattail fluffs floated up and settled itself in my pot. Now for the last 15 years, I've had a cattail, and I usually get one or two of them that pop up and flower every year. But yeah, kind of interesting. But they're great for wastewater treatment plants, and I see them used in a lot of green infrastructure just because they're very efficient at that. They do put out a lot of biomass, so sometimes it's going to be difficult to probably harvest that and get that out, but you can, and it sequesters it, so it's a good thing. Water hyacinths. So these are really efficient, very similarly, aquatic plants at absorbing those heavy metals and stabilizing and sequestering that stuff. These things will grow quickly. Mostly around here, you're going to see them used in little ponds, ornamental ponds, but they can take over aquatic environments and ponds. So you have to be careful. You'll usually find them more a little further south, but you can find them in the southern part of the metro area. They do wonderfully in polluted environments. So detention ponds and things like that makes them a good choice for putting in there. If you have a fish pond, just a little ornamental pond, throw a couple of these in there and they'll help absorb some of that fish waste. So they are often used as kind of a green solution for a pre-filtering or something like that in a wastewater area. Chinese ladder or brake fern. So this actually can tolerate very high levels of arsenic and lead. And sometimes if you have a shady area that maybe doesn't tolerate any other vegetation, these will be perfect for that. So it's going to actively extract that arsenic and lead out of the soil. Some soils are very high in that. We do actually have some of the soil around here in certain areas is high in arsenic. So that can be very useful. I believe these tend to be more tropical. I have to double check. I didn't put down the hardiness zone, but here it compartmentalizes it and preventing it from basically leaching out. But it's amazing how much I've got. If anybody's interested, I do have resources, scientific journals and such resources for each of these plants. If you're interested in them, I'm happy to save my sources. They're in my notes section here on the presentation. But very interesting how they can hold so much of these contaminants and they sequester them and the plant's not affected by it. So very low cost, plant them, forget about them, and it will kind of do its own thing, and it'll still look really pretty. Cotton, good old cotton. So it also absorbs heavy metals, leads, cadmiums, things like that, and it's pretty tolerant. So even though it's got the boll weevil, which is a problem, it's still a very good plant at uptaking a lot of these nutrients. So if you don't really care if you harvest anything off of it, the plant itself is pretty good at uptaking these contaminants and sequestering them. Clover, we all know this one, red clover, white clover, crimson, sweet, berseem clover, that kind of stuff. A very good nitrogen fixer and a very good cover crop, something that you can plant if you aren't going to use that area for a while or you want an alternative lawn. So an alternative lawn, your HOA is probably not going to be really happy about it, but if you don't have an HOA, this is a good thing to have out there. Bees love it. Love it. So you can definitely be helping the pollinators, pun intended. And this is a good option for that. So it will also add back decaying organic matter, and you might find a four-leaf clover and get some extra luck. I don't know. But it's great, a nice dense cover crop. So erosion, if you have kind of a slopey hillside and you need something to put on there, it's a good option. Sorghum, this is a crop, but it will absorb heavy metals. It's good at pesticide absorption, so that's an option. And that microbial community around its roots helps degrade and actually in a kind of a symbiotic relationship there. And, again, like I said, this is a crop. Sorghum is a kind of it's a syrupy kind of thing. Sorghum is used. It's used for a lot of things, but we actually do grow it around here, not in Gwinnett County. I don't think anything grows there anymore. But it also thrives in a lot of different soil conditions. So it's a good option. And that's it. Wow, I actually finished early. It's 6:52. So I have time for some oops, hang on. I'm going to leave up the there. I'll just put it up there. Um okay. So, let's pull up the chat, see what we've got. If there's any questions. Let's see. If you have questions, drop them in the chat box and I will attempt to answer them. When adding a cover crop like clover, first, how do you plant it with seeds? Yes. So you can purchase clover seed at most feed stores, and you would just kind of, I mean, you can go over it with a rake, the area that you're trying to plant it in, give it a good cut, the grass a cut if you've got tall grass on it or weeds, and then you're basically going to distribute the seed. And it's not going to be like really super dense at first. It's kind of something that, I prefer to add in a little bit at a time. It's a little more efficient at rooting versus Bermuda or some of that other stuff. So, but you do have to rough up the soil first. So you can disc it, but most people don't have access to that. You don't really want to till it. You don't need to do that. But if you can rough the soil up somehow, either get a riding lawnmower attachment and maybe like with an aeration attachment on there and go drag that around and then plant it, distribute the seed, you probably would have better luck. Then do you till the whole plant or mow off the top and just till in the roots? I guess you're talking about clover. So with the clover, if you're doing it for a couple years and then your intention is to maybe, I don't know, plant some other type of grass seed, or maybe you have a larger in-ground garden and you want to go back and plant tomatoes and stuff, you're actually going to have to till that under. So, again, you're using the clover mostly for nitrogen fixation. So, you know, that's what you're going to use it for. Not to say that you can't just allow it to go and grow there indefinitely. You're certainly welcome to do that. That can be an alternative lawn. It is used as an alternative lawn, and it's a very good pollinator plant because the flowers they're used pretty heavily by pollinators. So it's a good alternative. Not HOAs aren't really friendly on it, but if you don't have an HOA or you have a pasture area or you have a larger area in the backyard and you can get away with that, it's an alternative. Sorghum is used mostly for cattle feed. Thank you. Yeah, it's used for other things, but yeah, it's used mostly for cattle feed. It's silage. What heavy metals are pulled by blackberry and raspberry bushes? Do you pull the entire bushes after the season? So they're not really used so much as something that's planted for remediation. Blackberry will grow wild and especially down here. And it's not something that I would say, yeah, go run out and buy some blackberries and plant them in the ground. If you have an area that's contaminated, I would say you probably don't need to be planting in that area. This was more kind of a way to kind of inform folks what plants are actually doing out there for you, how useful they can be, where they're occasionally used for things like this. I could have taken a big deep dive into some cases of remediation where you can see what types of plants they're using. I would say sometimes they're more used in aquatic plants in water situations because you do have so much that flows into these detention ponds and the waters of the state, streams, rivers, things like that. And so I'm trying to educate folks. We've already done one on wetlands and rain gardens, and we'll be doing more. But trying to educate folks to try to learn how to keep their water on their property because a lot of this, when you have runoff on your driveway, when you have runoff from your yard, off the streets, it's pulling a lot of stuff. It's pulling fecal matter, it's pulling hydrocarbons, it's pulling other petroleum products, and that all ends up in the waters of the state. So it's kind of messy. So you can use plants judiciously to help keep that stuff on site so that it doesn't flow off site and cause problems other places. Let's see. Um, let's see. I joined late, but mostly watched because I have a small front yard garden with heavily compacted clay soil from development. I wanted to improve the soil health with no-till and was wondering your opinion on products offered by John and Bob's. Products like bacteria and other soil building amendments. You can build your soil. The no-till presentation that I did a couple weeks ago might help you a good deal on that because there was probably more in that one than there is in this one. And that one's already up at the Metro Master Gardener YouTube channel. So you can, the QR code there, you can hover over that with your mobile and it'll take you there and then you can subscribe. But that one talked more about ways that you can improve the soil if you have issues like that. If you have really poor soil, um, something that you could try. And again, I don't know, you said you have a very small yard, and if you have an HOA, they probably wouldn't allow you to really do this, but you could do like um, the radish method where you grow radishes in there and then they'll grow in the soil and then you basically just mow them down and allow them to kind of rot in place and they add the organic matter back. That's something you can do, but if you don't have that option and you're in a neighborhood, then you can take and basically till that area and you're going to till in some compost, organic matter. And what that does is that's going to add into the soil biome. So you're improving it. I guess I had some slides in here. I ended up taking them out because it talked about soil texture and things like that. That's a different presentation, really. But you can add and make your soil that you have there better by adding, if you have a really heavy clay soil, you can add in compost. You can add in a little bit of sand. So really you have about a 33% sand or 33% organic matter and 33% clay. And you mix all those together and that becomes a really nice soil mixture that your plant's roots will do much better in growing in. And so that I would recommend if you have a small area and you want to improve the soil, I would almost say start over from scratch, till all of that up, add in the good stuff, and then come back. And if you want to put some sod down, or if you want to do flower gardens or whatever you want to do, at that point the soil will be much better. Developers around here have a really bad habit of scraping this topsoil off and selling it, and then laying sod on top of hard pan clay. When sod gets laid down, it only has about a half an inch of topsoil associated with the root system. But when you throw that on hard pan clay, that's a next layer down in your soil horizon, and it's not topsoil, it's basically rock. It's not something that plants grow easily into. So you're already at a handicap. You probably need to kind of almost start over from scratch. And that's why I say top dressing. So adding more soil and compost matter to the top of your grass, allowing it to kind of be watered in, and then that adds and it'll grow over the top of it, and that'll make it a healthier set of your grass will be healthier because it'll have something to grow into. But that's probably what I would suggest. You can always email me and we can chat about it further. Let's see. Confused as to which plants you can still eat after remediation. If you're using them for remediation purposes, you probably should not eat whatever it is that you're getting off of them. Mostly like the blueberries and the blackberries and that kind of stuff. Um, I wouldn't go out and plant them with the intention of eating whatever it is if you know that you're dealing with a contaminated area. There's probably the need to have a professional involved in a situation like that. If you are using them for remediation, don't eat whatever it is that's on them. So you just want to use them as a plant to uptake that contaminant, and then you would not harvest from that. Um, I wouldn't be concerned of eating off the wild bushes in your yard unless you know for a fact that there was a commercially run garage, dry cleaner, something like that, farm right where your house is. I really wouldn't be too concerned about it. You really have to have the right conditions to be concerned. And I don't think most residential areas are going to have anything like that that they need to worry about. Did you know if, or do you know if we have bacteria in this that can infect you? So there's bacteria everywhere. There's bacteria growing on my computer keyboard because I didn't wash my hands before I this. There's bacteria everywhere. The types of bacteria that are going to be most detrimental to us are fecal bacteria because they can make us sick if we ingest it. Um, if you have a compromised immune system, you may have problems with other types of bacteria. But generally speaking, most humans are not going to have an issue with most of the bacteria that is out and about in this world that we live in. Now, if you get a cut and you're outside, yes, it can get infected because it's got a way to get into your skin, into your system. But our skin, our tegument, that does a fantastic job of protecting us. So really, there's nothing that I would be too concerned about with bacteria in the environment. Be more concerned with fecal matter, dogs, um, the runoff, that kind of stuff that ends up in streams after a hard rain. If it's muddy, stay out of it. If it's clean, it's probably okay to walk around in it. But after a rain, if it's muddy, stay out of it because the bacterial levels are going to be higher. Let's see. Clover. Winter crop in a raised box container garden. Do you till the whole clover plant into the soil in the spring? You can. Um, I might pull it and throw it in the compost heap because tilling it, You may get some pieces of it that don't decompose and then it pops back up again, and then you have essentially a weed. So in a raised bed container, you can pull it up and chop it up. You could do that. You could pull it up and then chop it up and then leave it laying there on the top to die and then till it back in. That would be more probably what I would recommend. You're welcome. Let's see what kind of bacteria were, oh, lost her limbs. Um, I'm trying to remember that. That's the flesh-eating bacteria. Strep or staph. Um, does anybody want to jump in? I know what you're talking about. Basically, it's the flesh-eating bacteria. Yeah, and she went swimming, and I think she had a cut or something like that, and she ended up. What it does is, well, you've got poor circulation in your fingers and your toes and your legs, and so it settled there, and that's why she ended up having to amputate because that's where it settled, and then it started to go necrotic and it killed her skin and musculature and all of that stuff. So she's very lucky she lived. A lot of times people don't. But it's staph or one of those. I'm sorry, I don't know off the top of my head. But yes, is that in the soil? Yes, it is. Are you going to get sick with it? Probably not. Should you wash your hands after you come in and after you've been rummaging around in the soil? Yes, you probably should, just to be healthy. And especially if you have a compromised immune system, that makes sense to make sure that you wash your hands and stay healthy because there are some things out there that you can get into, and you don't know if your neighbor's cat's been digging around in your garden either. So better to be safe than sorry. All right. If there are no other questions, if you have a quick question, last question, pop it in the chat box. If not, then that's pretty much it. And I'm going to go ahead and sign off for the evening. I do appreciate everybody coming in again. If you're here and you want a copy of the slide deck, I'm happy to share. Some people really enjoy going over those again and learning stuff. I'm happy to share it. You can email me. And other than that, that's basically it. So have a good rest of the evening. Thank you.